Hello and welcome to Year 11 General Maths. Today's the 19th of October. And I want to start with a brief review of matrices, which we introduced in yesterday's class. So here's an example of a matrix. Remember, we use capital letters to designate a matrix. And a matrix is just a rectangular group of numbers, such as this. So first question, I want to describe the order of this matrix. Most of you completed a textbook question on this yesterday. How could I describe the order of this matrix, capital A? Row and column. So, yep. So as I defined yesterday, it's m times n, where m is the number of rows and n is the number of columns. So here, there are 2 rows and 3 columns. Remember, the rows come first. Okay. I also define the following. If I write 2 subscripts underneath lowercase a, it is referring to a specific number in the matrix. That's right. So Jason has told us that this is 4. Why is it 4? Because 2-1 refers to row 2, column 1 in matrix A. All right, one more example. 2, 3. 7, very good. Okay. I'm going to build on this with a small example. The reason why I'm covering this is because this will come up in a multiple choice question on your Year 12 exam. It's not in your textbook, but I'm going to put this on the assignment. Construct a matrix Bij, just capital B, with 3 rows, 3 columns, where Bij equals I plus 2j.
What?
Yeah, I know. I had the same reaction from our Year 12s when we did this. So let's break it down. This matrix is going to have 3 rows and 3 columns. So let's start with the number in the first row and the first column, B11. So what I'm saying is I equals 1 and j equals 1 here. Okay? Chuck these numbers into the formula. We could use any letters. It's a good point, Jason. So mathematicians use I and j, usually. All right, you can use M and N, but talk to anyone who's done maths, they will probably use I and j, because it's the convention. Okay? All right, so thanks, Kalen. Yes, it is 1 plus 2 times 1. Okay, what about B21? So can you see that the numbers I and j, they can change depending on where I am in the matrix. So there's 3 rows and 3 columns. So I and j can take on the values 1, 2, and 3. All right. B31. What are my values of I and j going to be now? Yes?
Can you zoom in?
Zoom in. I can... So now it's really large.
We need 3 plus 2.
Sorry, Kaylin, what was that?
We need 3 plus 2.
Yep. So please make sure you get this down because there's an assignment question on this coming this Friday. Okay, so all I've done is the first. Have I done the first row or the first column here? That's right. So remember, Bij is the element in row I, column J. Okay. I didn't draw this yesterday, this matrix, but you should have this down as well. So just as a reminder, Bij means the entry in row I, column J. Now, I'm going to set this as an exercise. We've constructed the first column, right? Now, look at this formula here. There's a number, the number is 2 in front of J. So that tells me whenever I move to the next column, I'm going to increase the number by 2. So I don't need to repeat this calculation again. I can just write the matrix down like that. Okay? If you can't go straight here, start with one entry at a time. But eventually, as you become more experienced, you'll be able to go straight from the formula, Bij, straight to the matrix.
Will it ever be a times instead of a plus?
You can do whatever you want. But when this comes up in a Year 12 multiple choice question, it's usually something like this. Okay? Alright, this is a Year 12 level question. Right? Look at all these letters here. I and J and B floating around. So I'm trying to stretch you here. Okay?
What?
Extend you. Stretch you. Okay? Alright, would anyone like to ask any clarifying questions on this example before I move on? Okay? You may need to go over this again, and that's fine.
I don't need to go.
Alright, so I'll give you a minute to copy that down. Alright, Jazz, you done? You can always look at the sheet later, Jazz. Okay. Alright. I'm going to cover the next part of the textbook now, which is 5b. This part is nice and short. In fact, you've already seen this. So I'll actually make a note of this. You've seen this already under a different name. It was called adjacency matrices in the networks topic. All right, so let's do an example. Let's say I have 3 towns. Pick any 3 towns.
Yeah.
Marysville,
Okay?
Yeah.
Frankston.
Okay. This example may break, but we'll see what happens. So I'm going to call these A, B, and C. just to make things a bit easier for us. Now, one thing that we sometimes like to do is we like to represent with a picture whether different places are connected. So they could be connected by a phone line, a water pipe, a road network, or these could be people. So you could be connected via social media. You could be friends on Facebook. You'd have each other on Snapchat or Instagram. Okay.
You have Snapchat?
I do not have Snapchat. Now, let's see whether this will work. Can I get from Yay to Yark directly?
Sure.
Yeah.
Okay, they're not. Are they far away?
Not really.
Not really, right? Okay. So,
Switch over to Marysville and York. It's like basically.
all right. I'm still new to the area. So maybe Marysville should be further down, and C should be in the middle. Okay. So we're saying we can go from Yay to Yark. So I'm going to draw arrows between A and C. Okay? All right. Can I get from Yark to Marysville directly?
What is the recommend without going through?
So, yeah, it's up to us, right? So, can I get there via one main road? Or do I have to take more than one main road?
No. I think two.
Okay, what about Yay to Yark?
Yeah, it's near the highway.
One main road. Okay.
What's the route out to the section? No, then you have to turn off when you get to Duxton. So no.
So no. Okay, so this example is starting to break.
No, we're doing, so
You
doing
said
like
Yay to
that.
Yark.
Yeah, we're talking about
Switch.
Yay.
Okay. All right. Hey guys, I've got an idea. Jason, Jess. So I've got an idea. Let's say they're connected if we only have to take one main road. So to get from Yay to Yark, do you just need one main road or more than one main road? One main road? Okay, Charlotte says one main road. Okay, so we're going to say the town is connected if you only need to take one main road. But we don't think we can get from we don't think we can get from Yark to Marysville via one main road. Is that right? You think you need more than one main road? I mean, you guys live in this area. I mean, I do too, but I don't know this area as well as you do. So Yark to Marysville, you need two roads. Okay? All right, so by our definition, these two towns would not be connected, right? Okay, what about Yay to Marysville?
Yeah, you're back on the York Road, back that way, so you're back that way, Boston, and then you go the other way and then come out.
Okay, that's fine. So to make this example instructive, we need to add one more town. I think we need a town that is in between Marysville and Yark. Is there such a town?
What could that be?
Could that be us?
No.
No? Sarcasm?
Buxton.
Buxton? Yeah. Okay. All right. So is it Yark to Buxton and then Buxton to Marysville? don't play me, guys, because I'm at your mercy here.
Yes.
Yeah. Okay.
No,
No, you just sign
what was the question?
Just sign this box and Alex.
I need a town that is
Yeah, do Alex.
between Marysville and York that makes this work.
Yeah, Alex.
Yeah, okay.
Oh.
Okay, so do we agree with this diagram now? So I can go from Yay to York directly. I could go from York to Alexandra directly, and I could go from Alexandra to Marysville directly. We all okay with this? I'm trying to make this meaningful to you. Okay? Now, is there any other pair of towns? So right now I just have like one long road here. Can I draw any other arrows on this diagram? No, what I mean is between the towns that are already on the map. A to D.
Say to B, A to C.
Eyes already going, so.
Can I go straight from A to D
Yeah, why not?
via one main road?
Sure. Where's
No?
You have
Alex?
to turn off the
Where's Alex?
Okay.
Yay to Alex.
No, you can, because you can go that way, turn right, and it goes to the end.
No, you can't.
Yes, you can.
It's not one main road. It's not.
It is.
It's
Well,
not.
look, for the sake of the lesson, it is.
Okay.
You can't. This
So,
is
so okay. So Jason has given me an idea.
Just make up.
Let's imagine.
Please.
Let's imagine 50 years from now, they build a new road straight from Alex.
Can't just fix the ones we have.
Hey, a lot could happen in 50 years, okay? So just bear with me here, okay? I want to add one more edge to this network. Okay? So this network should now have 1, 2, 3, 4 edges and 4 vertices. Alright, is everyone okay with that? We've got a map, we've got some roads, we've got an imaginary road here as well. Okay, we're going to count this as part of our network. Now, why have we gone to all this trouble when we're doing a topic on matrices? Here's the reason. We can represent the information in this network in a different way. We can use a matrix. We already did this when we covered graphs and networks, and we did adjacency matrices.
Julian trail.
Okay?
Oil rein. Oil.
I know.
Oh, it's that thing.
Alright, so here's what's going to happen. Every time there's a road between two towns, I am going to add 1 to the matrix. If there's no roads, I'm going to put a 0. If there's 2 roads, then you put 2. In this case, there's only one road between each pair of towns, so there's only going to be 1s in this matrix, 1s and 0s. Alright, so let's start with A and A. Is there a road from A back to itself in this diagram now? Okay? So all the diagonals are going to be 0. Alright, can I get from A to B via a road?
No.
By one road? No. Okay, so these two numbers, row 1, column 2, and row 2, column 1, they're going to be 0. Alright, A to C.
Yeah.
Yes? So I'm going to put a 1 there. And likewise, so row 1, column 3, row 3, column 1. A to D, yes, as well. Alright, so I'll quickly fill this in with you. So I can't go from B to C. There's no road leading directly. Can I go from B to D? Yes. Can I go from C to D? Yes. So notice, if I fill in one half of the matrix, like this top triangle here, I get the bottom half for free. Next year we will call this a symmetric matrix, because it is symmetric, as the name suggests. So if you draw a matrix, if you get a matrix like this, and I ask you to write one, you should have the same thing on the top and the bottom, like here. We're going to do more with this later down the track. But for now, I'm just going to ask you to create this matrix. Later, we will do some applications with this matrix. The one thing I want to draw to your attention as well is that these two things, they look very different, right? One's a drawing with vertices and edges. The other one's a matrix, but they have the same information. So I think probably next week you'll see the things that we can do with this matrix. Now let me just check. Is there anything else? Are we okay with this? Do you want to do one more example? I mean, we already did this in the graphs network. Yeah. All right, so I'll leave it there. So come Friday, you should try to have 5A and 5B done, and we will do the next two parts. All right. Thank you.
And that's on the